Hello guys, so in this video we have to find the limit of this function. So first of all we will analyze the type of this function. This function is somewhat kind of fx to the power gx, where fx is 9x divided by 9x plus 9 and gx is 3x. So if we will analyze the form of this limit, so first of all we have to put the limit extending to infinity in this function, and then after we will put x is equal to infinity in this function. So if we will put limit extending to infinite, this is 9x. If we will take x common from here, so it will become 9 plus 9 by x. So we can cut x by x. So what it will become 9 upon 9 plus 9 upon infinity, so it will become 0, so it will become 1. So this is the form of 1 to the power infinite, because 3 into infinite is infinite. Now we have to apply the given formula, that I have written the formula already, that we have to take the log. So e to the power limit extend into infinite. So gx will, we will use the property of log, then gx will come in front, gx multiply by ln of fx. So we will write limit, so e to the power limit, this will become extending to infinite. So 3x will come outside and it will become ln of 9x divided by 9x plus 9. So now we will solve this limit separately. So what it will become? Infinite into 1. So it again in the form of indeterminate form. So to use this we have to change the format of this limit. So we will not write e again and again. We will consider it at the end of the answer. So it will become 9x divided by 9x plus 9 divided by, so 3 is the constant, so we can throw it out of the limit and it will become 1 upon x. We can write this x in denominator as 1 upon x. So now we will get the exact form. So we have solved it in the beginning, that this limit will be 1 and this limit will be 1, so it will be ln into 1 and divided by 1 by infinity. So it is again 0 by 0 form. We will use L'Hopital. So to use L'Hopital we have to differentiate numerator and denominator separately and apply the limit again. So limit extending to infinite, if we will, so it is ln x, so it will become 1 upon x. So 1 upon x, 9x plus 9 will be in numerator and 9x will be in denominator. And if we will differentiate this again, so it will become 9x plus 9 whole square. So it will become 9 multiplied by 9x plus 9 minus 9 into 9x. And this differentiation of denominator will be minus 1 divided by x square. So we have to solve this now. So to solve this, what we can cut this one time, so a square will be removed. So this is 81x, this is also 81x, so it will be cancelled, so it will be 81. So 9 again cancelled by this. So what we have got, 3 multiply limit extending to infinite. So here what we got, only 9. So it is like 9 divided by x multiply by 9x plus 9. So we can cut 9 by 9 by taking the common here. So we can write it as 1 divided by x plus 1, and this minus x square will be in the numerator, and we can also cut x by x. So what it will become? It will become x divided by x minus. So limit x tending to infinite, it will become minus x divided by x plus 1. So again, if we will put infinite, so it will become infinite by infinite form, and it is also linear function. So if we will take x common from denominator, so it will be 3 limit x tending to infinite, it will be minus x. So x, if we will take common, so it will become 1 plus 1 divided by x. So we can cancel x by x, so it will be 1 plus 1 upon infinite, so it will be 0. So 1 upon 1 will be 1. So limit value will be 1, and 3 is the limit value will be minus 1. So limit value will be minus 3. So final answer would be e to the power minus 3, because we have to use a here. So this is the final answer. So always remember, if we will get 0 by 0 form, then use L'Hopital rule. In this rule, we have to differentiate numerator and denominator separately till the time indeterminate form is not removed. So keep asking me questions in comment box, or please do visit my website. Thank you very much.